Hello, everyone, and welcome to the Switch Statement Podcast. It's a podcast for investigations into miscellaneous tech topics.
This is our 22nd episode on Gödel, Escher, Bach by Douglas Hofstadter.
Oh, hey, John. How are you doing?
I am doing really good. I don't know, just had a nice couple of weeks, been relaxing, been
Nice.
working on random things here and there.
What do you do to relax?
I like to cook. I like to run. I've been playing my piano a little more, which is good because, I don't know, just have been struggling lately to do that. So it's nice to like set aside time to do it. But yeah, I don't know how I relax.
Are you working on any particular pieces right now?
Well, there's a piece that I've always wanted to learn, the Chopin Ballad No. 1. I think it's like one of the greatest solo piano pieces, but it's very difficult. So it's like a little bit outside of my like ability, but that's good. It's something to shoot for.
That's the way to do it.
Yeah,
I feel like, you got to expand the domain of possibilities.
exactly. What about you? How do you relax?
How do I relax?
Yeah.
I avoid it if at all possible.
Yeah, you don't seem to. You're busy.
It's interesting because I think I do the same things when I am stressed and when I relax, but the distinguishing factor is like I don't have a deadline that's nearby. The same things. I like coding.
Yeah.
And I will do that, and that feels like rejuvenational. It rejuvenates me.
Rejuvenative?
But rejuvenative, yes, exactly.
I might have just made that word up.
Last time we were talking about the history of, the history of AI.
Right.
Like
ancient
history of AI.
Yeah.
And now we're talking about the future history of AI.
Yes.
The former future.
The former
of AI?
future. What was thought to be the future of AI in the year 1978, which is simultaneously hilarious, but also amazing. Just what he did sort of predict.
Well, this is the thing. Like, if you were going to talk to anyone, if anyone was going to come up with anything approximating a correct answer about this, it would be Douglas Hofstadter.
Yeah.
So, like, the fact that he gets some of it wrong is not, I don't think we should dig him too much for that.
Yeah, although we will talk about them because some of them were just utterly hilarious. Well, I thought they were hilarious. They're really not that funny. But another thing I wanted to mention about this book, and I feel like now is a good time to mention it. We had a great conversation with a friend of the podcast recently. I think that was the last episode that went out. And we sort of discussed like some critical aspects of Douglas Hofstadter. Like, he did get a lot of things wrong. He kind of, like, that whole biology chapter on DNA was basically like a big hand wave. And it turned out to not be accurate at all. And, someone published a white paper completely debunking it, which I think is good that people sort of critically examine these ideas and tear them down where possible. But I also love that Douglas Hofstadter is just kind of wildly tossing out ideas in this book. And some of them are just completely brilliant.
Well, this book is just a series of these, like, enormous ideas.
Yeah.
It's just like one after another. He'll just have a section where he introduces this unbelievably vast construct and then just, like, be like, well, that's a topic for another time.
Yeah. Well, right. And actually that segues into exactly what the point I wanted to make, which is like, I think this book was probably very inspiring to a lot of people. I'm inspired by this book, and it's 2025. It's like 50 years after he wrote this book. And I just wonder how much of today's AI advancement and like engineers working in AI, scientists being interested in AI, I wonder how much of that was at least partially inspired like by this book. And I would venture to say,
I'm sure a ton of it was.
A ton of it. So anyway, this is just me praising Douglas Hofstadter in spite of his obvious and many flaws.
One of my, I'm glad you're bringing this up because one of my takeaways while reading this book is I want to be the kind of person who discovers Magritte's human condition or what have you. You know, like my primary takeaway is Douglas Hofstadter just did like a ton of reading and looking around and consuming, and he's like I don't know, he's an idea collector.
Yes. Super multidisciplinary.
And this book is all about like sharing all of those ideas with the world.
It's a testament, and this really goes to your point, but it's just a testament to how the more well-rounded you are, the more ability you have to sort of come up with ideas that lay on the cross-section of multiple disciplines. Like a lot of these ideas that he's coming up with have been informed by his study of art and the hard sciences, you know, and I feel like without the confluence of those two things in his brain, these ideas might not exist.
I always go back to Jesse Schell's comment about this really advanced juggler. Do you remember this?
Yes. Yeah. It's a good part.
People were like, how do you juggle so well? Like, who are your juggling idols? Mm-hmm. And he's like, I don't look to other jugglers to become a better juggler. Like, I look to a swan, or I go to the ballet. Yeah. You know, and I derive inspiration from all these different sources. And that's how you become this much more like varied and complex and nuanced juggler and human, I guess.
Yes. And I also think it's important, this bears repeating, because I always felt a pressure to be as specialized as possible in my life. And, you know, I'm old now, so I can be a little reflective. Obviously, specialization is very, very valuable. You know, you have some expertise that you're just very good at and it's valuable, whatever. But I also think don't ignore being well-rounded. Don't ignore learning about art, learning about humanities, if you're interested in science like I was, because it will make you a better person. And I think it will make you better at whatever you choose to specialize in as well.
So I know we introduced this. This is about prospects of AI, but he spends a long time talking about these Vanguard problems. Yes. What did you think of these Vanguard problems?
I thought this was very interesting and, you know, somewhat dated because basically these Vanguard problems, and I don't even know if I'm going to describe this super accurately, but it's almost like a series of images.
The latest chapter in our "This is a terrible topic for a podcast" because these are highly visual problems.
Yes, yeah, they're highly visual. It's like these cards with, you know, drawings on them, and some of the drawings will be like, you know, 3 squares. Some of them will be like a big squiggly line. And I guess the issue is attempting to like discuss similarities and differences between these Vanguard cards, and sort of a discussion of like how might an AI discover differences between these things,
right?
And because, you know, for a human, it's fairly simple. You might look at something and you might say like, oh, everything has rounded edges, even though the images are quite different. You know, you could have an image of like a silhouette of a person, and obviously that's a lot of curves, and then an image of like circles. And one commonality you can draw from that is that there's a lot of curved edges. There's not any straight lines. Whereas a computer would have an extreme difficulty determining that potentially. I think that's sort of the point of these Vanguard problems, is to gain a better understanding of like how do computers differentiate between these things that are visually distinct in some ways, but visually very different in other ways.
Right. He used this term, or he had this phrase, which was, these are tiny science, like you do science in this like tiny little context.
Yeah.
Because it's exactly true, where it's like you have all of this data, which is this like raw, like pixel data essentially. But then you basically have to come up with a hypothesis. You look at a couple of these images, because maybe you said this, there's like 6 images on each side. And you kind of have to like be like, okay, well, I looked at 2 of them, so now maybe it's this this a relationship. But then you have to look to the other side to make sure that they don't have that attribute, and then confirm with all the other ones, which it is, it's, I guess it's just another way to think about what the act of like science is. And actually, I've never really thought about it this way, but it's like an AI is kind of doing science all the time, I guess, right? Like just with their visual and auditory input.
Yeah. Yeah. He talks about, he mentions, I think this was a phrase from the book, representing knowledge with nested frames, which is kind of like, it's an idea we've discussed a million times where there's so many different abstraction layers which you can look at a problem with. Like the example I like to give is there's that famous, you're firing a cannon off of a rooftop, and how do you calculate where its position after n seconds? And there's the famous formula, like negative 4.9 t squared plus vertical velocity t plus some constant, the height of the building. But you could also use general relativity to solve that problem. and those are basically two like drastically different abstraction layers to look at that. And he applies the same concept to Bongard problems where, you can look at things like count the number of things on each card. And that's one frame, through which to look at this. Or you could do what I was saying earlier, like look at the roundedness of the shapes. And these are just all kind of different frames which nest together. And it's almost like the summation of all of that is sort of what happens in a human brain. It's sort of like using all of these nested frames at once, sort of instantaneously. And it's also similar, I think, to what happens in a neural network, like in a large language model.
Right. Well, and he talks about this as well with, I think he used two terms. I think it's like focusing and filtering, where at every layer you have to do this discarding of irrelevant information and like a heightened focus on specific information.
Yeah.
And, we've probably talked about this before, but this dovetails like very closely with attention, right? That's this large language model mechanism that is kind of backing all of these latest advancements.
Yeah, huge advancement in AI.
And I think, and my understanding with attention is it actually learns, like part of what it learns is what to focus on. Like in a particular context, when it's being trained, like it's like, okay, well, in this context, these are the relevant things I should be looking at.
Right. And it gets
like
better.
That attention mechanism.
That becomes a skill, basically, that it has, is to like know what to focus on, even in a completely novel sentence.
Which this kind of like he talks about like meta descriptions, and it feels like this is kind of that like meta move where it's like, okay, first you're like operating at this lower level, which is like the words, but it's like, okay, well, there's actually this meta skill, which is like the relationships between the words.
Yeah.
And that is, you have to set up your system in such a way that it learns to do that, not just accept the words directly.
Yes. And I'm sure GPT users have had this experience where you ask it a question, but you ask it really, really poorly, and then it answers the actual question you were trying to ask. And that's like an even more meta thing, is sort of reading between the lines and like discerning what the user actually wants. And I'm super impressed by this when large language models get that right.
Yeah, really early on, it was funny because I was talking to someone who was really into it, was like, you don't even need to worry about writing your question particularly well. Like, it's just so good at understanding what you mean. Because, like, I have this thing where I'm just like, I will wordsmith even when I'm asking ChatGPT a question.
Yeah.
But it's like, I don't need to do that. It's going to figure it out. I could probably write it in completely broken English and it would still be able to figure out what I meant.
It's hilarious because when AI, when GPT 3.5 was released, like I joined an AI team at the company I work for. And I just remember all of us being obsessed with prompt engineering. Like we were all writing these like you're saying, just multi-paragraph prompts. We were sharing them with each other. We were saying like, oh, if you yell at it, it will do better. Or if you threaten it, it will, yield better results. And looking back on that, that was just ridiculous. Like you would just not, I mean, don't get me wrong, there's a lot of prompt engineering still going on, but just for a lot of the use cases that we were doing, like you could just, word vomit and these latest models are going to get it right every single time.
It's kind of hilarious to think that prompt engineering is the newest profession created by AI, but also the first the first profession to be replaced by AI.
Yes.
I guess it's fitting.
Yeah, I think I said this same phrase before, but I had written a note to myself about this chapter. This is like cave paintings of AI. Like he mentions at one point, words having spatial relationships with one another. Like a simple one being like the word high is above the word below. Things that are high are generally higher than things that are labeled with below. And this is so similar to a concept called an embedding space.
Yes.
Where in large language models, things, literally have an embedding associated with them, which is this vector of like a billion floating point numbers. And there is literal spatial relationships between these concepts. Like, and if you look at the word high in an embedding space and then look at the word below in an embedding space, they will have a spatial relationship with one another. And if you apply that same spatial relationship to a different concept, you can make that concept higher or lower, which is very strange. I don't know if I'm explaining that very well, but I just thought that section was interesting because, again, he's sort of touching on this idea that today is like very important and very, it's something that's an active area of research.
Yeah, embeddings are the kind of thing where until you have seen one and like poked at one, I feel like very hard to wrap your mind around what that means.
Yeah.
Not to mention that it's also confusing because it's got more than 3 dimensions. So
yeah,
which is like obviously immediately making it somewhat inapproachable.
Right. Yeah, embeddings, I feel as though embeddings are one of those things that we still haven't even scratch the surface on. Like they're so powerful. There's so much you can do with these relationships between concepts. But to your point, they're just hard to reason with. And they're hard to, as an engineer, it's hard to understand what's going on. And there's just not a lot of ergonomic tools for working with them. There are a lot. I mean, like there was a very recent thing that happened where GPT released its new version of DALL-E and everyone was creating Studio Ghibli pictures.
Yes. Yeah.
And all that is, well, I shouldn't say all that is. That's definitely removing a lot of nuance. But a lot of what that is applying like a Ghibli embedding to some other piece of image.
Yes.
You give it an image of a pot and you sort of subject that pot to this Ghibli directional embedding and boom, you have a Studio Ghibli pot.
Yeah, no, it's incredible. If listeners have not worked with embeddings before, I went through an AI boot camp and they started off by showing movies and like it was a one-dimensional embedding and it was between horror and comedy on the spectrum, so basically you could imagine giving everyone a score from 0 to 1 to determine like 0 is like you're the most extreme like horror movie and then 1 is like you're a comedy movie. Mm-hmm. So you could conceive of like, okay, well, if you make a new movie, like it's going to be somewhere in the middle of like you can place it somewhere on this line and you could or you could create a new point on that line and you could conceive of like, oh, it's something that's like a perfect split between a comedy and a horror movie.
Yes.
I don't know, maybe.
I was just saying, yes, I think this is a really powerful idea.
Right. So, but that's kind of like a way to think about it in like on one line where it's like, yeah, okay, well, I'm trying to come up with a movie that's like halfway between horror and comedy. There was that movie with Willem Dafoe and it just came out a little while ago. Anyway.
Like pretty.
It was pretty weird, but it was also
Pretty Little Things or something.
Pretty Things. Yeah,
it's interesting because in a lot of ways that is between comedy and horror, but it's also like very extreme on other axes.
Oh yeah,
which is another strength of multidimensionality is everything has thousands of axes that it can be imagined on, and multidimensionality allows you to achieve that.
Right, exactly, because you would want to have that off into some random corner of the embedding by itself.
Yeah, vaguely pornographic. Maximize the vaguely pornographic axis. Anyway, there was a bunch of other concepts he discussed in this. Like, he was basically predicting a lot of these concepts that are really important today. Like, he talked about message passing, having individual, he called them actors, that have their own sort of idiosyncrasies or own abilities, and passing messages between those actors. This is agentic AI. This is, he's basically describing agentic AI, which is one of the key principles of like modern AI development. And he's also discussing a lot of other things like tool use, this message passing. This is kind of like, there's a buzzword going around today, MCP, which is like model communication protocol or something. And so this is like a high level interface that enables models with completely disparate abilities to talk to one another. It's sort of like a contract it's like an API basically. And so anyway, I just, once again, like, this is Douglas Hofstadter basically predicting or, stating that this concept is going to be important. And like, here we are, everyone's funneling billions of dollars into this very concept.
That whole section has this really powerful idea, which is like the message, like you need to consider who's receiving it before you can really understand what a message means. Because if like you have a message written in French and you send it to me, I'm going to do something very different with it than someone who is able to read French.
Yeah.
So outside of the context of the actor, like you're saying, who like knowing who's going to get it, like you can't really know what the message means. And he calls this a symbol, which I don't love that. Like, I feel like that doesn't really capture the like dynamicness of what he's describing there.
Right. Yeah. Symbol seems like a discrete, singular, like atom. Man, I'm using like even worse words now.
Yeah, like a very tight semantic concept.
Yeah, exactly. Whereas this is almost like you're passing like a cloud of concepts.
Yes. Yeah, exactly. Should we get to these speculations?
Yeah, sure. Yeah, we can definitely get to the speculations. The first one I had written that AIs can't add. I think, and yeah, unfortunately, I'm forgetting the context of why I wrote this, but I think maybe he had said something along the lines of like AIs will be extremely good at like highly analytical tasks, and I just wonder what Douglas Hofstadter would think about the fact that AIs have trouble doing basic arithmetic.
Yeah.
I had also written, he said something along the lines of like AIs will never solve chess.
That one threw me off.
Yeah.
I think the message was more like, we're not going to have something that can beat anyone at chess until we have AGI, basically.
Yes, which he wasn't even close on that one. I mean, Kasparov
completely whiffed on that.
Yeah. Although it's interesting because I had to look up when the Kasparov Deep Blue thing happened, which is basically the first time a computer beat like a grandmaster. Garry Kasparov, one of the best chess players to ever live. This was in the mid 90s. So I guess he was right for about 15 years.
Yeah.
But now we have AIs that are just so incredible at chess, like no human would ever come close to beating them. Yeah. But those were the only two notes I took.
So in terms of the other predictions he made, there were two other ones that I thought were worth mentioning. Will a computer program ever write beautiful music? This was one where, I don't know. It's funny because I think there's kind of like split opinions about this. I think there's a contingent of people who are there's something essential about human experience that needs to go into music in order for it to be beautiful. And it actually can't be beautiful without a human having intention behind the music. I'm sympathetic to that view. I don't hold it, but I can see where they're coming from.
So I have always believed that music is sort of a sacred thing and that it is a part of human expression. But I also think that there's different types of music. and I think the same thing about film, where it's like sometimes you want a film that's just utterly formulaic, it doesn't really do anything new. Gerard Butler shoots a bunch of people, and that's great. But other times you want something that's more like a personal either experience or just like a personal vision that's completely original.
Yeah.
And yeah, the same thing exists in music. And so I kind of agree and disagree with the purists.
Yeah, no, that makes sense. The last one, just super quickly, was I thought it was hilarious that he said that people would never explicitly program emotions into the machines. He would probably not expect that people are using AI for their girlfriends and boyfriends in 2025.
Yeah. Yeah, no, that one was very amusing.
All right. I think that's all I got. Did you have anything else you wanted to mention?
That was all I had. I mean, another good chapter, hilarious discussions on the state of AI at the time, predictions, some of which very prescient, others of which hilarious. But yeah, just a fun read.
All right. Well, I will see you next time for chapter 20.
See you next time, Matt.